So what we're going to do now is look at multiplying and dividing algebraic fractions. Before we look at this topic, which will typically be in the new GCSE something along the lines of a grade 7, 8 or 9, we're going to need to first of all look at multiplying fractions if they weren't algebraic, dividing fractions if they weren't algebraic, and then looking at how we can make the process of algebraic fraction, multiplication and division a lot easier for ourselves. So hopefully you can see that this topic isn't actually as hard as it might sound. So if we start off with 2/3 multiplied by 1/4, to multiply this fraction we would multiply the top numbers together, so 2 times 1 to give us 2, and the bottom numbers together, so 3 times 4 to give us 12. We could then simplify this by saying the highest common factor of 2 and 12 is 2, so let's divide 2 by 2 to give us 1, and 12 by 2 to give us 6. And notice that we could have arrived at this solution a little bit quicker if we were to say the highest common factor of our numerator was 2 and the denominator of the second fraction is 4, so the highest common factor of these two numbers is 2. So we could have divided 2 by 2 to give us 1 and 4 by 2 to give us 2, and then done 1 times 1 to give us 1 and 3 times 2 to give us 6. So just make a note early on that this is a process which we could have used to multiply our fractions. It will be very useful, in fact absolutely essential later on. If we had 2/3 divided by 1/4 though, then what we would have to do is, for ease, turn it into a multiplication, and this is possible if we flip the second fraction. So only the second fraction. We can flip it, which would be 1/4 turning into 4/1. So notice what was on the bottom is now on the top, and what was on the top is now on the bottom. Once we flipped it and turned it into a multiplication, we can just perform the multiplication as we did before. So 2 times 4 to give us 8, 3 times 1 to give us 3. So that's our answer, 8/3. We could turn it into a mixed number if we use the bus stop, so 8 divided by 3, or 8/3, would be 8 inside the bus stop, 3 outside the bus stop. How many 3's go into 8? It's 2, and the remainder is 2. So this would be 2 as our whole, our remainder is our numerator, and what we're dividing by is our denominator. So 8/3, which is the same as 2 2/3. If we now look at a harder example, so if we had 12/27 multiplied by 9/4, this we could do as we did before, multiplying the top, multiplying the bottom, that would work. But let's get used to maybe trying to find the highest common factor of our numerator of the first fraction and denominator of the second fraction. So the highest common factor of the numerator for the first fraction, denominator for the second fraction, so 12 and 4, the highest common factor is 4. So if we divide 12 by 4, we'll get 3. And if we divide 4 by 4, we'll get 1. What we can do now is say, well, we can do that for the denominator of the first fraction and the numerator of the second fraction. So this sort of cross simplification can be done. 27 divided by 9, as 9 is the highest common factor, will give us 3. So 27 divided by 9 is 3. And then 9 divided by 9 would be 1. So now this fraction multiplication becomes 3 times 1, which is 3, and 3 times 1, which is 3. So 3/3, which is 1. Remember, anything divided by itself is 1. Okay, that's one of our very important rules. So if we were to try 14/15 divided by 7/5, if we remember to keep, change and flip, so 14/15, change the division into a times, and flip the second fraction so it becomes 5 over 7 instead of 7 over 5. We can now try and cross simplify. So highest common factor of 14 and 7 is 7. So we divide this by 7 and it will give us 2. Divide 7 by 7 and you get 1. So let's do the same to the denominator for the first fraction and the numerator for the second fraction. So highest common factor of 15 and 5 is 5. So this will become 3 and this will become 1. Now we can run along the top and run along the bottom. So 2 times 1 would be 2. 3 times 1, which is 3. And that is the answer to 14 over 15 divided by 7 over 5. So multiplying and dividing algebraic fractions. Multiplying algebraic fractions, let's cancel the common factors like we saw in the previous slide and multiply the numerators, multiply the denominators. So if we have this example here, the only difference really is that we've now got an a and a b. So we've still got this fraction and this fraction here, but now we've just got a couple of algebraic terms just to kind of ignore first. So 4 and 16, as we saw before, if we found the highest common factor of our numerator of the first fraction, denominator of the second fraction, then we can start dividing them by it. So the highest common factor here is 4. Highest common factor of 4 and 16 is 4. So let's divide them both by 4 and you get 1. And here you get 4. So if we do the same thing this time to our denominator of the first fraction and the numerator of the second fraction, our highest common factor of 5 and 15 is 5. So we divide 5 by 5 and get 1, divide 15 by 5 and you get 3. So and this actually now becomes 1a, so 1a over 1 multiplied by 3b over 4. 1a times 3b is going to be 3ab, and 1 times 4 is going to be 4, so that's our answer. We can't simplify any further. If you wrote 3/4 ab like that, you would still get the same marks. Okay, so 3/4 AB is the same as 3AB over 4. And this is going to show it. You could have just said 1A over 1 is just the same as A, but for just same thing written over them. If you have an expression like this, as you should always try and do with algebraic fractions, try and factorize first. So try to factorize first. Algebraic fractions are a lot easier to deal with if you try to factorize first of all. So we can't factorize the first term. We've got two separate terms here and they have nothing in common, so we can't factorize anything here or there. However, our second fraction can be factorized. So we can rewrite this now as n plus 4 over n minus 3 multiplied by 3n minus 9 over 5n plus 20. But instead of 3n minus 9, we can factorize out the top term. So 3n minus 9 would factorize to be, well, the highest common factor of 3n minus 9 is going to be 3. They don't share any common letters, so you can start with the bracket, and it's 3 open brackets n. 3 times n makes 3n. And then 3 times minus 3 makes minus 9. So 3 open brackets n minus 3. So we can rewrite this as 3 open brackets n minus 3. Our denominator here, 5n plus 20, do the same thing to. Highest common factor is 5, no common letters, so 5 open brackets n, because 5 times n makes 5n, and then 5 times positive 4 makes plus 20, so it's going to be 5 open brackets n plus 4. And what we can do now, as our highest common factor of this expression here, so n plus 4 is the numerator here, and we've got n plus 4 on the bottom here, multiplied by 5, we can actually cancel these out. So we can say, well, there's an n plus 4 here, and there's an n plus 4 here, so let's cancel them out. So that would effectively become 1, and this would become 5 times 1, which is just 5, so we'll keep it like that. Now, for the denominator for the first fraction and the numerator of the second fraction, we've got n minus 3. So let's divide them both by n minus 3. Effectively, that becomes 1, and that stays as 3. So 1 times 3 is 3, 1 times 5 is 5. And there's our answer. This expression here can be reduced to 3/5. dividing algebraic fractions, we're going to just do something very similar to what we did at the very start, and then just as we were with the previous slide, to be honest. So if we had 11 over 9x squared y divided by 77y over 15x, if we remember keep, change, flip, then we can change this to 11 over 9x squared y multiplied by 15x over 77y. Now, the highest common factor of our 11 and 77y, the highest common factor is 11. So let's divide this by 11 to make it 1, and we'll divide this by 11 to make it just 7y. So for ease of understanding, let's just get rid of that completely. And now our highest common factor for the denominator for the first fraction, the numerator for the second fraction, well, the highest common factor is going to be, for our numbers, 3. The highest common factor of 9 and 15 is 3. However, they've both got at least one x in them, so the highest common factor is 3x. So we can divide 9x squared y by 3x. 9 divided by 3 is going to be 3. X squared divided by x is going to just be x. So we're going to be left with 3xy. So 3xy. Remember, when you have x squared and you divide it by x, which is effectively x to the power of 1, it's going to be x to the power of 2 minus 1, which would be x to the power of 1, or just x. Admittedly, this is x to the power of minus 2 because it's as the denominator. However, for the highest common factor, we're just talking about this expression 9x squared y. So divide 15x by 3x as well. 15 divided by 3 is going to be 5. X divided by x cancel each other out, so we're left with 5. So let's rewrite that so it's a bit easy to follow. So we had 1 at the top here over 3xy. Once we'd divided this 9x squared y by 3x, we got 3xy. And 15x was simplified by dividing by 3x to get 5, and we were left with 7y on the bottom. So what we're going to have is 1 times 5, which is 5, 3xy times 7y, so 3 times 7 to give us 21, xy times y to give us xy squared. Y times y, remember, is going to be y squared, and the x is going to be sitting next to it. So, just in case you wanted to see it again, that's what we'd end up with. If you wrote 5 over 12 and then xy next to it, you would still get the mark. So as long as your xy squared needs to be on the bottom. So if you did write 5 over 21 xy squared, that would be incorrect. Okay, the xy squared in this case needs to be on the bottom. It is part of the denominator. It's being divided. 5 is being divided by xy squared, so this would not be correct. So this is where they might start ramping up a bit more, and if we've got this expression on the top here as a quadratic and a quadratic on the bottom divided by this quadratic and this linear expression, first thing we're going to do is try and turn it into a multiplication. So if we've got x squared minus 4 as the numerator in the first fraction, we'll keep it there, and this is going to be x squared plus 4x minus 32 as the denominator, and we're going to change it from a divide to a times and flip the second fraction as we did before. So 5x plus 40 now goes on the top. It was on the bottom, it's now on the top, and what was on the top is now on the bottom, so we get x squared minus 5x plus 6. So now let's try and factorize some of these. X squared minus 4, you might recognize as the difference of two squares. So it's like one of those terms like x squared minus 9, where it would be double brackets, and it's going to be x and x, but it's going to be the square root of 9, so it's going to be plus 3, but it's also going to be minus 3. That way, when we expanded it, we got rid of our x term by itself, and we're left with 3 times minus 3, which is minus 9. So x squared minus 4 is actually going to be x plus 2 and x minus 2. So the square root of 4 was 2, so it's going to be x plus 2 and x minus 2. Okay, these are the kind of terms that you should be able to recite very quickly in the exam, because it's going to be something which, if you don't see straight away, it might take a bit of time to see, so worth revising some of the difference of two squares. X squared plus 4x minus 32, so we're looking for numbers that multiply together to make minus 32. So multiply together to make minus 32, but add together to make plus 4. So numbers that multiply together to make 32 but add together to make 4 is going to be 8 and 4. To make minus 32, one of them is going to need to be negative, and if we're trying to make plus 4, then it's got to be positive 8 and negative 4. So our denominator for the first fraction is going to become x plus 8, x minus 4. If we find the highest common factor for the numerator of the second fraction, it's going to be 5 open brackets x plus 8, and the denominator for the second bracket is going to become x minus 3, x minus 2. Again, we're looking for numbers that multiply together to make this time plus 6, but add together to make minus 5. So minus 3 minus 2 is going to be minus 5, but minus 3 times minus 2 is going to be plus 6. So now what we can do is start cancelling out. So we've got a minus 2 on the top here, x minus 2 inside the bracket, so we can cancel that out with the x minus 2 on the cross numerator and denominator. So x minus 2 is the numerator of the first, x minus 2 on the denominator on the second, so we can cross them out. We can also say, well, x plus 8 is the denominator in the first fraction, and x plus 8 is the numerator of the second fraction, so we start crossing them out as well. So what we're left with is x plus 2 times 5, so 5 open brackets, x plus 2, 5 lots of x plus 2, and x minus 4, x minus 3. So x minus 4 times x minus 3 would look like this, and that is as far as we can go. Remember, with algebraic fractions, we'll try and keep them in simplest form, and simplest form is going to be in our factorized form. So remember to simplify these as far as is possible. So if we've got a few questions here now for you to try, if you pause the video, attempt some of these questions, and then we'll just cover over what we should have done before we have a problem-solving kind of question that I think might be the style of question that they throw up in the new GCSE. So if we look at question 1, we have 5y over 3 multiplied by 9b over 25. And if we start off by cancelling out, by cross-simplifying these fractions, so 5 and 25, the highest common factor here is 5, so it's going to be 1y over, and then here 9b over 5. If we do the same to these two, the highest common factor was 3, so this will be 1, and this will be 3b. So this would end up being 1y times 3b, which will be 3by, or yb, doesn't matter. 1 times 5 to give us 5, and that's our answer. 3by over 5. For our second question, we're going to have to factorize as far as possible. So factorize the denominator of the first fraction, which would be 6 open brackets p minus 2. And if we factorize the denominator of the second bracket, we'll get p minus 2 on the top, which can't be simplified, but we can factorize out 10 on the bottom. So 10 open brackets, n plus 5, which would end up being, if we simplify, because we have the numerator on the top of the first fraction, so the numerator of the first fraction has n plus 5, but the denominator of the second fraction has n plus 5, so we can cancel them out. Then the denominator of the first fraction, which is p minus 2, and the numerator of the second fraction, which is p minus 2, cancel out. And so we're effectively left with 1 here and a 1 here. So 1 times 1, which will be 1, and 6 times 10, which will be 60. So this can be reduced to 1 over 60, or 1/60th. For this algebraic fraction, remember what we're going to have to do first of all is turn it into a multiplication. Before we try any cross simplification, it must be a multiplication. Okay, so we must change this into a multiply. And to change it into a multiply, we need to flip the second fraction. So 8 over 9xy squared. So 8 over 9xy squared multiplied by 18x over 64y. Now we can start cross simplifying. And the highest common factor of the numerator of the first and the denominator of the second is 8, so let's divide them both by 8, so that'll be 1, and this would be 8, or 8y, for completeness. And the highest common factor of 9xy squared and 18x so would be 9x, so let's divide them both by 9x, and you will get just y squared on the bottom here, and 18x divided by 9x is going to be 2. So 1 times 2 is going to give us 2, and y squared times 8y is going to be 8y cubed. Notice here though that we do need to simplify this fraction a bit further, because 2 over 8 can be simplified to 1 over 4. So it's going to be 1 over 4 y cubed, and that will be our answer. So with our question 4, hopefully you recognise the difference of 2 squares on the top of the first fraction. So this would simplify to be x minus 13, x plus 13, square root of 169 is 13. And the denominator of the first fraction would simplify to be, so numbers that multiply together to make minus 48, but add together to make positive 8 would be 12 and 4, but it would have to be positive 12, take away 4 to give us positive 8. So it would be x plus 12, x minus 4. So what we're doing here is going to try and do all of this in one go. So I've actually I've skipped the step of flipping this fraction. You may have wanted to turn it into 2x plus 24 over x squared minus 10x minus 39, and then try to factorize that from here. So this would be 2 open brackets x plus 12 on the top, on the numerator. Remember, I've put that on the top. And then the denominator would be, so numbers that multiply together to make minus 39, but adds together to make minus 10 is going to be 13 and 3. But it's going to have to be minus 13 and positive 3 to give us the minus 10. So x minus 13, x plus 3, and let's cross simplify now, because we're in that stage of multiplying. We've got x minus 13 on the top of the first fraction, x minus 13 on the bottom of the second fraction, so let's start cancelling them out. And then x plus 12 on the bottom of the first fraction, or denominator, and x plus 12 on the numerator on the second fraction, so we cancel them out, and we have 2 times x plus 13, so 2 times x plus 13, we've got 2 lots of them, and x minus 4, x plus 3 as the denominator. And that is as far as we can go with this, so that will be our answer. So finally, a problem-solving algebraic fractions question. What is the area of this football pitch? I'll give you the time to pause the video if you want and try this kind of problem-solving type question for algebraic fractions, one that I made. I think that this is the kind of thing that they would throw up in the test. But as an extension, what is the area of 3 of these next to each other? So if you visualize 3 of these next to each other, what would the area be? So to start off this question, we're going to realize that as we're trying to find the area of what we assume to be as its football pitch, let's assume it to be a rectangle, although it wasn't said explicitly in the question. Hopefully you gathered that it would be a rectangle. And if we try and find the area of that rectangle, it means we're going to have to be multiplying this expression, so this length, by this expression, which will represent this length. So instead of writing them out, I'm just going to try and factorize them before I multiply them up here. So let's try and factorize these before we multiply them. So x squared minus 7x plus 12 would end up being x minus 3 and x minus 4. Minus 3 times minus 4 to give us the plus 12, but minus 3 plus minus 4 to give us minus 7. And difference of 2 squares on the bottom, so x minus a, x plus a. The numerator for the other fraction would have been x minus 8 and x minus 9. And for the denominator for the second fraction, you could factorize out 3, so 3 open brackets, so just make that a bit more clear, 3 open brackets, x minus 4. Now we can cross simplify. We have x minus 4 on the top here, x minus 4 on the bottom. We then have x minus 8 on the bottom of the first fraction, and x minus 8 on the top of the second fraction, so they can cancel out as well. And we're left with x minus 3 times x minus 9, so x minus 9, over 3 lots of x plus 8, so 3 lots of x plus a, and that would be our answer. The area of that football pitch in that expression, obviously we need meters squared, don't forget your units because we're talking about meters here. For the extension, if we are trying to visualize it, we've worked out the area of one of these. We've actually got another 2 here, so we've got 3 lots of them, so we just need to multiply this by 3. So as we have a 3 as the denominator on the expression, if we multiply that by 3, remember when you're multiplying a whole by a fraction, it's just going to be 3 times the numerator. So 3 lots of the numerator, which in this case would be 3 times 1, which is 3 over 3. Denominator stays the same, so 3 divided by 3, which would be 1. Well here, as there's no number before this expression, this is the same as saying 1. So we've actually got this 1 over 3. Times it by 3, so it's 3 over 3. And they would actually cancel out. So your answer would be x minus 3, x minus 9 over x plus 8.